I mean, so far I'm liking what I'm hearing. Definitely something I want to start implementing and messing around with.
Yeah. So I mean, you can, if you want, we can walk through like a quick task or something, and you can start seeing how it works if you want, and ask questions as we go through. If you want to do that real quick.
Yeah.
All right. So let's see. I know John's complained about a couple things why he's been using it over the last few days since I did the Swift version.
What are
All
those
right.
things you've been talking about?
Huh?
What were the things he's been talking about? I don't.
I created tickets for them all. So there's one which is when doing a get PS pull and a rebase fails, it swallows the actual rebase error. So we could do that one. That would be a pretty easy one.
All right.
There's also this one he ran into, which is if a user has echoes in their bash profiles, it makes the get PS fail. I mean, I guess this is a more critical one. We could fix that one. So, okay, so it's got to figure out where Git is, right?
Yeah.
And so the way it figures out where Git is right now, here, let me open the package. Let me open the project file. Okay, so it's not super big. I mean, it's a lot bigger than the bash version, but most of that is just because like we have to figure out how to interface properly with external commands in Swift.
Yeah.
It's not as easy as it is in Bash, but we get a lot more flexibility for doing things like state management, persistence, etc. Um, so like I created this little run wrapper. I have two ways of basically executing external commands that I put in here. I have run, which runs a command and then grabs standard error, standard out, and um, also the status code that the command exited with. And then I have another command I wrote which kind of interacts with the C library execv, which replaces the current process with another process of an external command, right?
Yeah.
Um, and so those are the two. And so the way I kind of architected this, granted, there's like no tests on any of this right now. This is really just like kind of a spike to get something working. And so the architecture is not the prettiest for sure. Like there's a lot to be cleaned up, but I just wanted to get something working and kind of make sure that it kind of is the way I want it to be from an interface standpoint, and that the state management was what I wanted. So the way that I did this was I built this bash class, and I did this so that I could implement which like exists on the command line, right? Where you say which and you say which git and it returns user local bin git, right? I needed some way to get the path for git. And so in order to do that and use run or whatever, right? In this case I'm using that run method I wrote. I need to basically get the path to bash, which we know because we're on a Mac, right? So we know it's in bin bash for sure. Right. And then I run bin bash -l, which does a login shell, -c, which says run the command that's given to you in the following string, which runs which, and then whatever the command name is that's given to it. And then we say if that succeeds, cool, grab the path, which was the standard output, trim white space characters and new lines, and then send that back, right?
Yeah.
Otherwise, error out. So I think this is fine. But the next layer up from this is Git shell, which is a class that is responsible for interacting with Git via the shell, right? Or via external commands. And so it takes in a dependency injected bash class instance, and it uses that to figure out the path for Git right here.
Right.
And so it says self path equals try bash which Git. So the situation that he ran into was that he had, it sounded like a bash profile where he echoed some stuff out for whatever reason, right?
Yeah.
And then if we run bin bash -l-c which Git, we can see the output isn't just the path. The output is those echoes and then the path. And so it was breaking Git Patch Stack for him because it was seeing those echoes as part of the path, right?
Right.
So we can. I looked at Bash to see if there was any way to tell it to ignore output from, the scripts that it loads. There's not. So we kind of have to figure out some solution inside of here. So the thing I was thinking was it's always the last line, right?
Right. So you can always split by line breaks and pull that one out.
Yeah, we could split by line breaks and pull that one out. The only tricky bit maybe is what happens if you do a which and it doesn't know where that is. In that scenario, it doesn't give it's not the last line, but we get an exit status code here that is not success. We get an exit status code of 1. So we should be okay.
Right, so
yeah, so here we check the status code right here. So here we say if the status code is success, then
pull the path out of it.
Then we get the path out. We read standard out and set path equal to that. But that's not actually what we want to do. We want to say, like, if there's output on standard out, then we want to do like output dot split on new lines or something. And then we want to say like last. Can you just say last?
Yeah, you can just pull it out of last. Yeah.
And that gives me a substring. So then we'd have to be like if that gives me an optional substring. So then we have to be like last line. If there is a last line, then
up there.
I guess that's the path.
Yeah.
And then we could say, well, we want to do last line. Maybe we do dot trimming.
Right.
We'll do that whole thing. And then we have a path, right?
Right.
And then we can just return path. Well, we got to return string of path because it's a substring. It's not a string.
Right.
And then we can say. So then we can say output expected but was missing. And this can go away. And cool. So what do we want to do in the case that...
You can combine this all into one line too, because you're going to be basing off of the standard output. So just combine this line into here. Make it one giant if statement, if output and path of the output.
Wait. What are you saying?
So you can basically put both of these lines into one statement. So use the output, comma, then let path equals output split all in one if.
Oh, I see what you're saying.
Yeah. Then you have to do with one error case.
So we're saying if this, then if that.
Get the path, return the path, and then otherwise throw an error. Yeah.
All right. Why is it unhappy? No such module JSON. Xcode. Why are you being silly?
Did not fetch it.
Didn't fetch. It didn't fetch the packages. Something's wrong. Let's close Xcode real quick.
Start again.
Yeah, let's just do it this way instead. Instead of opening the project file, let's just open the folder.
Yeah, that's how I usually do it. It works better that way.
Yeah. Okay. So now it's building. Sweet. Okay. So we made a change. So we can test it real quick, I guess. So I have a make file that I set up in here to manage the build of it for local builds, as well as installing it locally. So I can just do make, and it'll build it appropriately using Swift Package Manager, and then I can do make install. But actually, before we do that, let's brew uninstall git ps. Cool, and then let's do make install. If I could type. Cool. So git -ps, and that's there. Okay. So if we run git ps with nothing, it says invalid argument count, which makes sense because we haven't told it anything. I run git ps ls, and it doesn't complain. That's good. So let's stash those changes. Let's do another build, another install. Let's do git ps ls. Ah, it pukes.
Yeah.
And that's the error that he was seeing before as well.
Right.
So it seems like our fix is working. Cool. So now if we do git ps ls, it works, right? So let's add our first patch onto our stack. So now here's our diff. Looks pretty good.
Yeah, a couple of changes.
Not too bad. So what did we do? We fixed bug where shell config output broke git ps. We did this so that users who had echo statements in their shell configurations, so for example, .bash profile, etc., could successfully use git ps. Previously, it would fail to run any command because it was unable to successfully find the git command. The reason it was failing was because the which implementation was reading all of standard output in as the path rather than just grabbing the last line of standard output as the path. Hence, we modified it to now grab the last line as the path. Yeah?
Yep, that sounds good to me.
Cool. We commit like we normally do. The other benefit of this workflow, Anthony, that I haven't run into this where I needed to do this yet. But behind this, like, it's all Git, right? Like this, it's just a wrapper on top of Git. And so behind the scenes, it's just doing Git commands for you. So you always have the flexibility to break out and use Git. You could use branches. You could do whatever you want, right? Like however you normally use Git. So there's no like limitation, I guess, is my point, right? It's not like you're locked into some new workflow. If you ever find a place using this workflow where you feel like you're stuck and you can't do it this way, there's nothing preventing you from going and doing it, the way you are used to with feature branches or whatever.
Right. You still have the ability to use both.
Yeah, exactly. So now I just did git ps ls. So now we see our first patch in the stack, right?
Mm-hmm.
And we can see this number here on the far left. That number is the patch index. So when you do a git ps, it lists out all your patches and it gives you your patch index. So this is the 0th indexed patch right now because we only have one. And this is the short version of the SHA of that commit. And then this is the summary of that commit. Now, what you'll see here is right now this is blank. But this is where you'll get state indication of that patch. And so let's not worry about the state information yet. Like maybe we go tackle another one of these just so we have 2 patches to play with. So this guy, let's say closing because it is in mainline now. Or it's not in mainline now. We can't actually close this.
Right.
Well, let's not close that yet. We should assign that to ourselves, though.
Yeah, you don't lose it.
All right. John might pop in here and tackle it. You never know.
Right. He sneaks around.
Yeah, he does. All right. So when doing git ps, so this one should be easy. It's even easier. So this is when doing a git ps pull, and you like behind the scenes that does a fetch and it does a rebase. And so when that rebase fails because of a conflict or whatever, like a rebase would normally fail. Right now, it's swallowing the error output. So that should be a pretty easy thing. So let's go find that. So the main entry point for this is this main Swift file. And so what I did was I created, basically I have this Git Patch Stack core. Because my thinking with doing all this was like, I should make kind of a library that I could reuse in a GUI, right?
Right.
And then the command line tool can just kind of be command line, the wrapper that interfaces with that library. And so the way I kind of started doing that was just created this Git Patch Stack class, like module, and then main just calls that, right? Just calls run on that.
Yeah.
And then if we go to run, so here this thing just has a constructor. The constructor takes arguments, which are the command line arguments by default, are dependency injected into that. And then right now it has a remote and a base branch. that are passed in by default as origin and master. Those are stored, and then it creates an instance of Git shell and stores that instance of the Git shell class. And then we have the run command, which gets called from main, and that just looks at the arguments, does a switch on the subcommands, and then goes and executes various other functions based on that, right?
Yeah.
So like ls just calls list, show just calls show, etc., etc. So we're talking about pull. So let's go look at pull. So pull is right here. So pull grab does the first thing it does is it gets the .git directory URL. It tries to find that. If it doesn't find that, it errors out. And then once it finds that, it creates a request review repository based on that, which is actually what the state that is managed. So in what's the best way to look at this? Just look at this. So in the .git directory, Git Patch Stack goes and creates this patch stack review requests JSON file. And right now that file is empty because we haven't actually stored any state in it yet. But I'll show you once we create this second patch, I'll show you when that gets updated. But the reason it grabs it in here is because we have this cleansing process that happens at the end of a pull where it goes and cleans up any stale state that we don't care about anymore. But before it gets to that, we do a fetch, and then we do a rebase. And so this is swallowing the error messages. So that git shell, so in the git shell class, there's a rebase method that says rebase onto whatever you pass it, from whatever to whatever. And that is swallowing the error messages. And I can see exactly why it's swallowing error messages. Because we're not doing anything with the standard out or standard error that we get from it.
Right.
So yeah. So right here. So we have this result class that we get back. And the result class has a Boolean that tells you whether it's successful or not, which is a computed property based on the termination status that we get back. And then it's also got optional string for standard error and an optional string for standard out.
Which is just those two cases.
Yeah, and so right now it's just throwing this get rebase failure error, which is what John reported seeing. And he was like, hey, this get rebase failure error is not useful because I don't know why my rebase failed, because it's swallowing the output.
Right.
So we got to decide what we want to do inside of this. Do we only show standard error, or do we show standard out and standard error?
You kind of would need both in this case, wouldn't you?
I don't know. Like I think it depends on the command.
Right.
I mean, maybe it's safe to always just print standard output and then print standard error. I guess. I don't know. Maybe it's something we should just try.
Yeah. And refactor later.
Yeah. So we'll do if let result standard output if let error output. And we could do something as simple as this. Right?
Right, and that will give you all three cases.
Yeah. So if it succeeds, we don't get any output. If it fails, then we get whatever standard output is present, then we get whatever standard error is present, and then we also get the throw of get rebase failure. Yeah?
Yep. That would cover it all.
You see a better way of writing this?
No. I mean, that's probably the easiest and cleanest way right now, since you're not using any sort of coloring syntax either.
Yeah. All right, well, it builds, so can do make.
Make install.
Make install. Let's do a get PSLS. Let's just run it to make sure we do a get PS pull. Oh, cannot rebase. You have unstaged changes. Please commit or stash them. Well, that's cool.
At least we're getting errors now.
We're getting errors now. What happened? Yeah. I feel like we're getting extra new lines though.
Because
I'm pretty sure this blank line here is a side effect of printing an empty string.
Right, so then maybe check if it's empty as well.
Yeah.
And output dot is empty, I think.
And output. Oh, can I do that?
You gotta use commas. Yep. And then you want to be just like that. And the same thing for error.
All right, let's make sure we get a new build, and then make install. Okay, so now we get PS pull. There we go. That seems more reasonable.
There we go.
All right.
Yeah, and cleaner.
Let's commit this bad boy. So we fixed bug where get PS pull was swallowing rebase errors. So I'm kind of a stickler. Like, are you familiar with the Git commit format?
A little bit. I just tend to try to keep everything as concise as can be and generate a manual pull request description rather than things.
Yeah. So there's actually like a specified. And this also comes from the kernel team, but there's actually like a specified limit for the length of the summary, and a limit for the width in terms of columns of the content area below. And so that, like, Vim, the way I have Vim configured, you'll notice is like when I get there, you can see it turns to like white text instead of the colored text.
Right.
And so I try to always like back it up and create a more concise message when I hit that limit. But it's beneficial to abide by that because it just makes the summary work better with all the tooling. Fix bug where get PS pull was hiding rebase error. When you would do a get PS pull, it was not outputting the errors from the rebase command, which would leave you hanging when conflict arose. This takes and outputs the standard out as well as the standard error when present, resolving this issue. Yeah?
Sounds good to me.
All right, so now if we get patch stack ls, now we have two patches in our stack. We have patch index 0 and we have patch index 1, right? And they're fixing two different bugs. Let's go back here and make sure we claim this one too. Okay, so I know we keep talking about them as patches because that's what they are conceptually, but in reality, they're just commits, right?
Right.
So we can do whatever we want with these commits. We can do a get ps pull, right? And now that we don't have local changes, it works successfully. We can do a get ps rebase and be like, hey, like we actually don't like this order. We want, you know, this one to be fixed before that one, right? So we can do an interactive rebase, and now our get patch stack, they've shifted, and now 0 is the one that fixes the error hiding, and 1 is the one that, you know, messes with the configuration with the shell configuration.
Right.
So this is kind of the whole workflow, is that like constantly what you are doing is doing a get ps pull, which pulls changes from upstream down into your local copy and rebases your stack of patches on top of those new changes that you just pulled down, right?
Right.
So your stack of patches is effectively always just getting replayed on top of the new stuff. And as you're going through your work, let's say we forgot to, let's say we actually want to reference the ticket descriptions from GitHub in those commits, right? In the commit messages. We can just go back and do that, right? We can do it, get ps rebase, and then inside of here, we can be like, cool, well, we want to actually, you know, reword this commit. So we change that to an R. That takes us in here, and then we can be like, this, it presents resolving the issue. And we can even say like this resolves issue number 9, right?
Yeah.
And then get ps ls. That one's good. We can go find the other one and be like,
I believe.
What'd you say?
I think it was number 7. Yeah.
Yeah?
Yep. Further down.
So we can get ps rebase. We can go to this one and we can do reword this one. And we can do this resolves issue number 7. But it doesn't have to stop there, right? So like we can also do things with interactive rebases to like add commits in between commits in our stack. Or we can squash two commits together, right? Like let's say, you know, we decided to go in here and we decided to address this interactive scenario, right? So this function also supports doing interactive rebases. Now, in this case, it actually uses the replace process. So when the rebase command fails, the output will naturally happen. So there's nothing to do. But let's say we wanted to put a comment in here that says that, no, we don't need to handle explicit error output here because this replaces the process and therefore all standard out and error output will naturally end up in the shell, right? So let's say we want to make that change. We can do that a couple ways, right? We can go in here, we can be like, cool, let's make a commit. We can then add comments, or we could just be like, hey, we actually don't care about this because we want to squash it into something. So we can just give it a garbage commit message, get PS rebase, and then we can say, cool, I actually want to squash that into this one. Change it to S for squash. And then it gives me in here, I can adjust the commit message if I want, but in this case, I don't really want to. And now we're back to our Git Patch Stack of 2, but it includes that. And if we get PS show 0, we can see in the diff and the output that we now have that comment in there.
Right. Yeah. Okay.
So the idea is that you like constantly like work your patches until you get them into a state that you're happy with. And we haven't really seen it in this example because these are independent patches. But like when you're doing outside in development, you know, where you like start at the UI and you work your like way down and down, like more inner and more inner and more inner until you get to that core thing where it's a logical change inside that is really a dependency of all these different layers. The beauty of this now is that when you get to that, you can be making commits all the way along this path. You can have like an incomplete commit for the UI layer, right? An incomplete commit for, or a patch for, you know, the next layer down, the next layer down. And then let's say you get to like your persistence layer, and your persistence layer needs a new method added to it. Well, you can create a new patch that adds that method to it, and that's at the innermost layer, and right away you can submit that patch for review even though all the other stuff isn't done yet. Whereas in a feature branch workflow, you basically have to wait for all of that stuff to be done before you can submit it for review.
Right. It's a lot. Skip the line.
Yeah. So let's, now that we've implemented these, I think they're in a pretty good state, both of them. So let's do a patch stack request review of patch 0. So you can just do git ps rr and then 0 to request review. Right now I have it dumping a bunch of debugging output about all the crazy things that it's doing to make this possible. So if you're interested in that stuff, we could talk about some of that. But conceptually, the idea is that you shouldn't really have to worry about that. You're just saying, I want to request review from this. It does some stuff with branching and creates a branch for you and then pushes it up. And then it outputs this link, which you can just click on. That takes you to your default browser, and here you go. It's got the commit message filled in. We can preview it. It's got linking with the ticket number that we added. If we create the pull request, we can now see it's got the diff right here with the files changed. So yeah. I mean, that's kind of it, right?
Right.
And then let's say, well, so to show you the state tracking stuff that we have. So you now see if you run git ps, it shows you that patch 0 has had a request reviewed, submitted for it. So you can look at your list and know which of your patches you've requested review of.
Yeah, so that way you're not going to create something twice or forget what you've done.
Yeah, and it also, if we did like let's do a git ps rebase real quick. So if we get ps ls now, oh, it didn't change anything. It was a fake rebase. I guess I'll just do a real one. Let's do a git ps rebase and then change this guy. Let's just change the description again. Fix bug where git ps pull was hiding rebase errors. Let's say errors. Okay. So I've modified that commit. So now in git ps ls, it knows that that patch has had a review request submitted for it, but it knows that there's been changes made to it since that, right?
Mm-hmm.
So it's telling you that, you may want to think about resubmitting it for review now that you've made changes, right? So we can do git ps rr0 again, and that will then push those changes up to the pull request for us. And that also updates state. So now we don't have RR plus, we just have RR, right? So it's in a good state in terms of request review. So that's all cool. And then let's say, let's just pretend that we had somebody who reviewed this and approved it, right? I can't approve my own, but or maybe I can. No, pull request authors can't approve their own, even though I own the repo. But yeah, so
right.
We could just we can do a publish of it. So you do get ps publish 0, right? And that's it.
And that merges everything in.
So what that actually does is that merges it into and pushes it into remote's upstream's master. So if we were to look at the Git tree right now, so you can see head master is what we're checked out on, right?
Yeah.
And that's actually our patch stack. So this was what origin master used to be, this 4049954. And now, because we just published that, origin master is now this F035E83. Right?
Right.
So we've effectively published that up to the remote. And if we even looked at GitHub, it's in GitHub, right? It knows it's merged in GitHub. And if we look at the actual commits,
and then underneath the map,
if we look,
see there it is.
Yeah, it's right there, fixed bug, right here. So it's been published up to upstream, but we don't know locally. We still have it in our patch stack. And so here's another piece of state that we track and manage, is whether or not a patch has been published or not. So now we know that we have this patch locally here, but it's been published to upstream. And so the way that this workflow works is that basically if you do a git ps pull, all of your patches that are already published to upstream will basically disappear, because Git is smart enough to know when you pull those changes in, even if the commit SHAs are different, it's smart enough to know that those patches are exactly the same. And so it basically drops them. So, but the reason that we have this publish state is so that I could actually publish multiple things, right? So let's say I wanted to also publish this before I pull new state down, right? I could do a git ps publish, and I'll do a -f for force of patch 1. And the reason I do a force is because I haven't requested review of that patch yet. So it's like you're in cowboy. Phil recommended changing it from -f to -c for cowboy mode.
I like it.
Yeah. So we may have to do that. But yeah, so that's pushing it up. And then now if we get PSLS, now we see both of these are published, is their state in our patch stack. If we look at our Git tree, we now have both of those in origin master. And this is what origin master used to be, remember, and our patch stack sits on top of that. So now we want to do a git ps pull, which will lift our patch stack here and replay it on top of origin master. But now origin master will have the patches already that are currently in our patch stack, So our patch stack will effectively become empty, right?
Get cleared out. Yep.
So if we do a git ps pull, git ps ls, it's empty. If we look at the git tree, it's totally linear, right? That's the other super benefit of this, is that your git tree ends up being linear as the end result of this. So when you're trying to like go back in history and figure out what got screwed up, or find a commit to revert, or figure out where you should tag something, it's all super easy to understand because you don't have all these intricate branching things going on all over the place.
Right, which screws up the whole tree layout to figure out what's going on.
Yeah, it makes it super difficult. So, but this is super easy. So that's Git Patch Stack, man.
I like it. I'm going to get this installed and start testing it out.
Yeah, totally. You can install it.
Used to.
Huh?
It's definitely going to take me some getting used to.
Yeah. I mean, it's a different mentality. I think that's the biggest thing. For me, it was not a big switch because I was like constantly going back and forth between like giving up on trying to do best practices and just doing classic feature branch workflow, and fighting feature branch workflow and doing best practices. And so when you're already making super tiny pull requests and super tiny commits that are super well focused and well documented, but you're using feature branches, it's just a lot more kind of like crap that you have to deal with to do that. Whereas now I do that stuff and I don't have all the extra layers of crap that I have to deal with around it. It's just natural because each commit is effectively a thing that I'm going to submit for review. And each commit is a thing that's going to be buildable and testable. And so once you make that switch where you're like, yeah, each commit's buildable, each commit's testable, and it's a logical unit that is going to be submitted for review, then it's just like, cool, you just work that way, and everything goes smooth. But yeah, I submitted it through, we have a brew tap, so you can install it just via Homebrew.
Yeah, let me get that moving now.
But yeah, this is the other thing. This is the other thing that I started out with. I don't know if you're familiar, but like when you do a Git pull, you can actually configure Git to do a rebase for you when you do a pull instead of doing a merge.
Yeah, I've always stayed away from a pull because of that merge. I really thought there was a way to do that.
Yeah, so I recommend adding this to your Git config just in case you forget to do like a Git PS pull and you do a normal Git pull. It'll just do the right things anyways. Right. And then I have a little blurb down here where I started trying to write, what is the patch stack workflow? Kind of explain that a little bit. It's complicated. I feel like it's complicated to explain. I don't know.
Yeah, like it's one of those things you actually got to start to mess with to understand.
Yeah. But like the workflow itself is not very complicated. Like there's like list your patch pull, rebase, request review, and publish.
Right.
Like there's not that much to it. It's just I threw in here. Oh yeah, I threw the presentation I did in here. So inside the Git repo, there's a presentations folder, and then I have the Uptech brown bag, and then the deck that I used.
Okay.
But this is kind of like a summarization of like all the stuff. But this is what I kind of gave in that little internal little powwow presentation. And people were like, I think visuals would help.
Yeah.
And it's like, yeah, it's like one of those things you kind of just gotta try. Like you gotta see it in action or feel it in action
To understand it. Right.
Yeah. And so maybe I should make some like little screencasts or something of like examples of using it. Um, but other things people brought up were like long-lived branches. People were like, well, how do you deal with long-lived branches with this? It's kind of interesting because your stack is effectively a long-lived branch that just continually gets rebased.
Right.
So you can move you can move your patches that you want to be long-lived, like leave them in your stack up at the top of your stack or at the bottom of your stack, wherever makes sense. You can leave them there and just never submit them for review, right?
You don't have to worry about them, yeah.
And you can still use them locally and keep working on them locally. And that's actually what some of the kernel dev teams do, right? They basically have their branch and they manage using a separate tool called Quilt. They actually manage effectively a stack of patches using Quilt that they receive from all of the people that submit them to the mailing list, and they manage stacks of patches on top of their local Git trees. And then only a portion of those patches actually make it into upstream in the next release, but they still keep them around in their local tree as effectively a long-lived branch. And then, they gradually move their way up, right?
Right.
But yeah, there you go. Holy crap, it's 11.
I know.
That's 2 hours of Patch Stack, bro.
Gotta love the tech talks.
Gotta love the tech talks. Cool.
All right, well, thank you, Drew. Appreciate the rundown.
Yeah, anytime, man. Any other questions?
I'm just trying to think. No, I think I'm good to go. I just got this installed, so I think tomorrow morning when I get started, I'm going to start messing around with this.
Cool. All right, brother. Hit me up when you run into issues or have any questions or whatever. I'll try to get these. Maybe I'll cut another release tonight. I'll ping you once I do that so you can install one with the fixes that we did tonight.
Sounds good. Yeah, so I get the latest and greatest.
Yeah. Cool, bro.
All right. Thank you, Drew.
Yeah, no worries. Talk to you later.
You bet.
All right. Bye.
Bye.